Hey, when you guys look at x plus 4 squared, what do you know about the parent function? Parent function is 4 to the, oh my gosh, answer my question. 4 to what? Left. So we go 4 to the left. Oh my gosh, Hitler. Is there any stretch? Any reflection? Anything else other than 4 to the left? So move it. 4 to the left. 1, 2, 3, 4. Draw your parent function. This one, I did not rescale it to find the y-intercept, but that's not going to be our main focus today. That's okay. It says label the vertex and the axis symmetry. What's our AOS? X equals X equals -4. Vertex -4, 0. So this next one, where's the vertex?
2 to -6.
Excellent. Thank you so much. It is at +2, -6. And is there a stretch on this one or a shrink? Is there a reflection on this one? So then it's just the what's it called? Parent function things. Now, before you go to the next page, because graphing is so much fun and we want to work ahead, before you go to the next page, AOS, sorry. AOS, X equals 2 vertex, 2 -6. Before you go to the next page, today we're going to work on x-intercepts a lot. We're going to x-intercept. So when you look at these graphs, where on graph 1 do we cross the x-axis? On graph 1, where's the x-axis? Where does it intersect? -4, 0. That's the x-intercept. And there's only one. On graph 2, where does it cross the x-axis? It's not -1 because there'd be a dot on it. You did try. Appreciate it. But it is close to -1, but it's not -1. How would you describe that? Between 0 and -1? A decimal? Something that's kind of hard to find by looking at a picture? Yeah. And same thing with this one over here. I don't know what it is by looking at it. I, as a teacher, do not know what it is by looking at it. I would have to solve it, and I'll teach you how to do that stuff. But by looking at it, I couldn't tell you because it's decimal. Yeah, so this one copied weird. Sorry. The equations are in the front, but the graphs are in the back. I think it's because the first one, the graphs copied weird, but sorry about that. What was I going to say? Yeah, number 3. That's where I was. Number 3, let's graph that one. What do we know about the vertex? It's in vertex form. It is at -3, -3. And there is a reflection on it. There's a vertical stretch. I could take the time to create a table and find all these ordered pairs right now, but I'm trying to save a little bit of time, okay? So I will tell you the graph looks like this. Okay. Where are the x-intercepts?
There is none.
There is none. Exactly. So this could be a question that we have, and your answer would be there would be no real answers. There would be no real solutions. There aren't any answers. Number 4 we can do. Number 4, where's the vertex? Or the AOS? Where's the vertex? This is vertex form. What's in the parenthesis with the X? There's not a parenthesis, so what's in the parenthesis with the X? 0, because there isn't a parenthesis, so it's 0. And the Y value is 4. 0, 4 is our vertex. Axis of symmetry, X equals the X value of the vertex, 0. Using transformations, it is up 4, but also what? Brianna? Reflection in the x-axis, so it's going to go down, and there's no stretch. So it's just the parent function face down, where we go out 1, down 1, out 2, down 4, out 3, down 5, or 9. Just the parent function facing down. And then I say, where's my x-intercepts? Can you tell that one? Yeah, where are they? -2, 0, and 2, 0. And we could tell that because our parent function points just happen to go right through those, so it's pretty easy to find. So we've done all the cases of what you will see if you graph the equation and try to find your x-intercepts. You could have one x-intercept, which is our first one. You could have 2 x-intercepts that are not at nice numbers. You can't solve it by graphing. You can't find this by graphing. You could have no x-intercepts, and you could have 2 x-intercepts that you can solve by graphing because they hit at nice easy points. If I ask you to solve it by graphing, it should never be the kind that you can't find. The B, the second one, where there were decimals. I'll never give you that kind and say it has to be by graphing because you can't. Well, you can, the calculator, but we'll do that to save that for this talks about some vocabulary where the quadratic equation, ax squared plus bx plus c, we've been doing that, standard form of that. When I ask you to find the x-intercepts, I may phrase it in different ways depending on what the equation looks like. You may hear it phrased like the solution of the equation. You might hear it phrased as finding the roots of the polynomial. You might hear it phrased as finding a 0 of a function. So you might hear roots, you might hear zeros, you might hear solutions. You might hear x-intercepts. These are all used for different purposes, and I'll try to show you that as we learn them, but they all mean the same thing. You're going to find them in the same process. These are the 3 processes we're going to learn today. Today, solve it by graphing. We started looking at x-intercepts by graphing. Using a method called square rooting, which you've done square roots before. What's the square root of 9? 3. What's the square root of -4? No. What's the square root of any negative number? Do we need to type in the calculator? Do you know? No. It doesn't work. You can't do it. It's not a real answer. It's only imaginary. Huh? Well, then it wouldn't be a square. Right? Right? That's why it doesn't work. Okay, but we'll get at it a little bit. And then the third case is by doing this by factoring. And gosh, we just spent like a few days on factoring, didn't we? Okay, these are the ones where I said some of you have different things on your paper than me. I've like changed it, but then I didn't change your paper, so I apologize for that. But we're going to solve these equations by graphing. So the first one, x squared minus x minus 6. That is actually, you know what, I'm not going to do all of these. No, I'll do this one. This is kind of a pain, but that's all right, we can do it. X squared minus x minus 6 is in which form? x squared plus bx plus c. So how do we find the vertex in the AOS when it's in this form? Negative b over 2a. Let's do it. So we're still using that stuff from last chapter. Just because we took an exam on it doesn't mean we can throw it all away now. We're still using the same stuff. Math always grows on what you learned before. So we do negative, and then b is negative 1 over 2 times a is 1. Axis of symmetry is x equals half. And then we plug that in to our equation to find y. Oh no. What am I missing from this equation? Huh? The y, it's like gone. Where would it normally be? If this was ax squared plus bx plus c, where would y be? Oops. Oh, my computer's having bad issues today. It's going crazy, just heads up. And I'm frustrated since 6 failed that's doing it. Okay, but that's where the y would be, where that 0 is. So when we're solving something by graphing, we're trying to find where y is 0. We're trying to find on the x-axis where this graph is, because that's all the ordered pairs where y is 0. So when I'm finding my vertex and I'm plugging in a half, I'm still finding the y value. So I'm using the equation where y equals x squared minus x minus 6. I'm using the equation with y to solve that. So I'm doing half squared minus half minus 6. And I do it really magically fast, and I get negative 6 1/4. See how fast that was? So my vertex is at half, negative 6 1/4. We go graph it. Half, negative 6 1/4 is about there. What else could we find to graph this? Something else we found like every time we graph stuff. What else have we found every time we graph stuff? Every time. Every time. What do we find? What do we find? Every time we graph stuff. The axis symmetry, the vertex, the y-intercept. Thank you. What's the y-intercept for this one?
0, negative 6.
0, negative 6. You are rocking it today. Now there it is. 0, negative 6. Oh, it's really close together. That's not giving me a whole lot of information. How do I find more points? David, how do I find more points? Yeah, whatever number you want. Okay, we'll plug in 1. Oh no, I'm not gonna plug in 1 because 1 was my mirror to the y. So I already know that one. 2. Okay, we'll plug in 2. So we plug in 2. I'm going to get 2 squared minus 2 minus 6. That's negative 4. So 2, negative 4 is a point. No. What am I trying to find again? Where it crosses the x-axis. So that got us closer. Let me plug in 3. Should I plug in 3? Okay. So if I plug in 3 squared minus 3 minus 6, that's going to give me 9 minus 9. Ooh, 0. So the ordered pair 3, 0 is one of my solutions. And when I mirror that with my AOS, which I didn't draw in, when I mirror that with my AOS, it gives me the other x-intercept. Now, the directions were not find the x-intercepts. They were just solve for x. So I'm not going to put ordered pairs. I'm going to write this as a list of answers. So I'm going to scroll down so I can write my answers. The solutions for x equals, there's two of them, -2 and +3. I did not write an ordered pair. How can you tell by looking at those numbers that they are not ordered pairs? That is not an ordered pair. How does it look different than an ordered pair? It's not the parentheses. It's the fancy brackets, which mean a collection of numbers, a set of answers. That just means these are individual answers for x. Okay? So when you solve by graphing, you're just finding where the points hit the x-axis. X-intercepts. We're going to skip B. We'll find a better one.
What are those fancy brackets called?
Brackets?
What was the difference between that and like a square bracket?
The fancy?
I've heard of that.
I don't know. I actually don't know. I'm just making stuff up. I always call them fancy brackets. So. No, you know what? I don't like any of these. Let's go back to this one. And I'm actually going to use the one you have on your paper for this one because I like yours better than mine. So you just have a 4 here, not a 4x, right? Okay. So in order to solve this, I need to know where the y is in the equation, and the y is where the 0 is, but I don't see a 0. So what should I do to this equation? What should I do? I don't see a 0. I need to see a 0. Ideas? Natalie? Subtract 4 from each side. That would give me a 0. Okay. And then that would be like -2x squared minus 6 equals y. But we're going to find where y is 0, so we're finding the x-intercepts. Now we can graph this. This is in standard form, but it is also in vertex form. And I prefer vertex form when it comes to graphing. Well, I can use both forms. I prefer vertex form because what's the vertex? What's in the parentheses with the x? What's in the parentheses with the x? There isn't a parenthesis, so 0, yes. And then what is the y value? We can talk transformations. What is done to the x? What is done to the y? The y is down 6, and then what's this -2 do? When you talk about transformations, what's the negative do? Flips it, what the 2 do? Stretch it and flip it? Okay, but we know the vertex is at 0, -6. There we go. All right, and I don't actually need to find anything more. I'm just imagining right now there is a stretch and then there is a flip. Where's this graph going to go? What are my x-intercepts? There aren't any. Because there aren't any, but we're not actually finding the x-intercepts, we're finding the solutions. You're going to write no real solution. Because there are imaginary ones. There's just no real one. For real though. Okay. I know you can like never read because you can't tell if I'm being sarcastic or not, but there are really imaginary answers. We just want to learn them today. You're just putting no real solution. All right, moving on. Next section. Next section. So the first section was solve it by graphing, solve it, find the x-intercepts. Graph it, find the x-intercepts. Next is solving by what's called square roots. Have you ever taken the square root of a number in a previous math course? Yes. All right. So to solve this by square roots, you have to isolate whatever is squared. We have to get that by itself. We have to isolate it. So what is the furthest thing away from x squared that you can get rid of? What do we do to solve this equation? Carly. Furthest thing away from x squared that I could get rid of, so x squared can be isolated. What's the furthest thing away? So now it's on the equal side, on the other side equal sign. On the same side, what's the furthest thing away? So how do I get rid of a minus 31? Add it, right. Again, we are trying to isolate x squared, so now what do we have to get rid of? Right. Divide by 4. So I have x squared equals 20. I now have isolated the squared part. At this point in time, I now have to undo squared. What cancels out? What is the inverse operation? What is the opposite operation of squared? Square root. Oh yeah, she gave us that clue earlier. We're going to square both sides, square root both sides, but if you put in a square root, you have no idea what x was originally. Is that correct? You have no idea what that number is because it's variable. If that number was negative and I squared it, it would give me a positive answer. If that was positive and I squared it, it would give me a positive answer. I just don't know if that number was negative or positive to begin with. So you have to assume it could be either, and you put the plus minus in front of that square root. So if you are putting the square root in your equation to solve it, if you put that thing in, you also put a plus minus in front. Every time. So now we have two answers. We have that x could be positive square root 20, or x could be negative square root 20. And I personally am efficient and don't want to write square root of 20 twice, so I put plus minus. But you could write it, if you want, as the square root of 20 comma negative square root 20. You could write it separately. That's okay. But this is not the final answer. Because we didn't see if we could actually square root 20 yet. Can you square root 20? Not even, right? So how would I find the square root of 20? Oh no, we're not going to use our calculator. Stop that. If I type in calculator, it's going to give me an approximate decimal, which is good if you need to plot it, if you need to graph it. It's good to know that. But in a previous course, you should have learned about simplifying these. And I'm going to go over that right now. Is that what you're going to say from that? What are you thinking?
Like you go to the nearest root, square root to like the one, but it might be wrong.
That would be what it would be, in between. Are you thinking like in between square root of 16 and square root of 25? Yeah, so that's when you're just approximating it. But if we're going to find the exact simplified answer, what you want to do is you want to make a factor tree with square root 20. And you have to say, what two numbers do I multiply together to give me square root 20? To get a square root, they both have to be square roots. And when you're thinking of these two numbers, I can think of three possible answers right now, three possible sets of factors. I want to think of one that has a perfect square in it. So what times what makes 20? And one of those has to be a perfect square. One of those I can square root. 2 and 10? No. 5 and 4? I'm going to put the 4 first, because the 4 is the one that is the square rootable one. And when I take the square root of 4, I get 2. And when I take the square root of 5, I can't. So I just bring it down and I put it next to the 2 because they are multiplied together. The square root of 4 times the square root of 5 is the square root of 20. So when I simplify, it is now 2 square root of 5. 2 multiplied by square root of 5. I bring the plus minus down in front. So there's two answers. You can either write them as x equals plus minus 2 radical 5, or you could write it as negative 2 radical 5, comma, positive 2 radical 5. You can write them separately or together. I prefer together. Okay. So this is solving by square roots. What do we do for this one? We got to isolate the squared. What should we do first? What's the furthest thing away from squared? Brooke, what should I do? Okay. Tim, what should I do? Okay. Shiloh, what should I do? Okay, so by square root, what do I also have to do? I'm going to put plus minus in front. And then I say, can I take the square root of a negative number? Square root means something times itself, and there's no way that I can multiply a number by the exact same number and make it negative. It would have to be positive and negative together. So the answer is no real solution. There's imaginary ones, but no real solutions. All right, the next one has a typo on it. Mine is correct, yours is not. It should say 2/5, parenthesis x plus 3 squared equals 5. We are isolating whatever is squared to begin with. So this time, there's a binomial squared. I gotta get that by itself. What do I do first? What's 2/5 in front? What's the operation, Ellie? It's multiplication. And how do I cancel out multiplication? Division. But do I want to divide by a fraction? What do I do instead of divide by a fraction? Just that. Multiply by its reciprocal. So to both sides, we're going to multiply by 5/2. And over on this right side, 5 is over 1, and I multiply by 5/2. So I get x plus 3 squared equals 25/2. On the other side, the 5/2 and the 2/5 cancel out. That's why we multiply by that to make it cancel. So here, I've now gotten the squared by itself. The squared is the outermost thing. So that's the next thing I do is square root. But what do I have to do if I square root? Plus or minus. If I square root, I got to do plus minus. Square root undoes squared. So we have x plus 3 equals plus or minus square root 25/2. Now I do have a little bit more work to do on this one. Just heads up for space or wherever you are in your paper. I have a little bit more work to do. The next thing I'm going to do is I'm still going to get x by itself. Zena, what should I do next to get x by itself? Subtract 3. When I subtract 3, you're going to see this a lot. When there's like a plus minus, I don't put the minus 3 at the end. I don't do it there. I put it in the front as a negative 3. So I have x equals negative 3 plus or minus square root 25/2. And I do that so that we aren't confused if the negative 3 is under the radical or not. It's definitely outside of the radical, so I just put it in front. Now, what I'm saying about I've got some other stuff to do is because I know square root of 25/2 is not simplified. Okay, I know it's not simplified. Square root of 25/2 is the same thing as square root of 25 over the square root of 2. And if you know that fact, what's the square root of 25? Brianna, what's the square root of 25? No. What's just the square root of 25 on top? Oh. What times 7 makes 25? Thank you. That's what I was asking. That's all right. So now I've simplified the square root of 25. What you should have also learned in previous course, fingers crossed you've learned this, you're not allowed to leave a radical in the denominator. Did you learn that ever? So the answer is no. You're going to be spending some time with me next age. Okay? So you're not allowed to leave a radical in the denominator. So when I have 5 over radical 2, I have to do what's called rationalizing. I have to multiply the top and the bottom by a value of 1. It's just like taking a fraction and reducing it, or taking a fraction and giving it a common denominator with something else. We're going to multiply the top and the bottom by something that changes its appearance but not value. I'm actually going to multiply by square root of 2 over square root 2. When you multiply a number that is a number with a number that's a square root, you can't multiply them together, so you put them next to each other. On the bottom, when you multiply a number that is a square root with a number that is a square root, you can multiply them together under the square root. So square root of 4. And then we have one more step to simplify it. What is the square root of 4? So we have 5 square root 2 over 2. I can't cancel the 2's because one's a square root and one is not. So this would be our simplest version of that. So our final two answers, x equals, fancy bracket, -3, plus or minus that. 5 square root 2 over 2. So that's two answers. That's -3 plus 5 square root of 2 over 2 and -3 minus 5 square root of 2 over 2. I would say that would probably be the most difficult thing that you have because we haven't spent a lot of time reviewing radicals. We will spend time reviewing radicals eventually in here and they'll get like more complicated. But if you need a crash course, how are you going to get a crash course? If you need it, what are you going to do? XH. How many XHs do you got before you see me again? 2. No excuses. You got 2 whole XHs. Come get help if you need help on that part. All right, the last section. We're going to skip this. The last section. This is going to be your favorite. So I know factoring is your favorite, isn't it? Remember? We did it last week, factoring. All right, take that little quiz. No, we'll keep practicing it. Okay, so to do factoring, to solve by factoring, we're going to use something called the zero product property, which says if I multiply stuff together and it equals 0, what does it tell me about the stuff I'm multiplying? At least one of them is 0. Both is 0. But if I multiply two things together and the answer is 0, at least one of them's got to be 0. That's a zero product property. It's got to equal 0. So when we find solutions, sometimes they are called zeros of the function, and it has to do with this. So our first, example 3 is x squared minus 4x equals 45. I'm just going to write it bigger because it's really tiny up there. And we're going to solve this by the method of factoring. And to do the method of factoring, we have to have the zero product property. So this has to say equals 0. Does this say equals 0? Does it? No. How did I make it say equals 0? Subtract 45 on both sides. Boom. Equals 0. Now, we're going to factor it. So we're going to do what we were working on last week. And there are a few steps of factoring. First step is always the same. What's the first step of factoring? Always. Is there a greatest common factor? Is there? Is there a number that divides out of x squared, 4x, and 45? There is not. So we just move on. How many terms does it have? 3 terms. And for 3-term factoring, what is that called? Nobody remembers? No, but that's 4-term. That's 4-term. It does start with a G, though. Maybe I'll remember it as we do it. How do I know what goes here? Unfoiling. How do I know what goes here? For It'll be x and x, right? Well, we're just like looking and we know that this x times x has to give it. X times x has to give us x squared. We know that. How do I know it goes in the other spot? Has to multiply together to give us negative 45. So what do I know about the signs? One of each, right? And to make 45, it could be 1 and 45, 3 and 15, 5 and 9. I think that's it. What should I put where so I get a negative 4 in the middle? What should I put where though? Positive 5 and negative 9. How do I know I did it right? Foil it back together. It starts with a CH. Oh, nobody remembers what this is called. Guess and check. Thank you. We just guess stuff and we check it. Remember that? All right, good. You know what to do. You can remember what it's called. That's what we're going with. Okay, so now we're going to solve for 0, and you should have seen this before. Does this look like intersect 4? How do we find x-intercepts? Set each of them equal to 0 and solve. That's what we're doing. We're just doing it not as x-intercepts. We're doing it as solving for x. So we do x plus 5 equals 0, and x minus 9 equals 0. Then we subtract the 5, we get x equals negative 5. Add the 9, x equals 9. And we have two solutions, negative 5 and positive 9. So the same stuff we did before. Oh, there was a reason why we were doing that. Yes. Well, it should all start coming together. It's not all going to make sense after the first day, but the next one says find the zeros. Now, when it says find the zeros, it's giving you an equation like f of x, and you just have to know that we're trying to find. Oh, wait 8 minutes left. Same. You have to find. Oh, do you have your passing? Okay. It's on Big Ideas. The numbers that correlate to the book are in Canvas. So if your Big Ideas doesn't work at home, you do the stuff in the book and then come in and on these 2x ratios, plug it in. Okay. When it says find the zeros, that's just saying wherever y is, make it say 0. So wherever y is, make it say 0. That's what finding the zeros is telling us to do. So wherever the f of x was, we just say 0 equals and stuff. And then we do the process we did in the first one. The first step was make it say equals 0. Okay, did that one. Second step is what? Factor. GCF would be the first step of factoring. Is there a greatest common factor? 2, 11, 12. No. So then it's 3 terms. So we're just going to do this by guess and check. 2x has got to be 2x and x. There is a positive 12 at the end. So that tells me both signs are the same. And then that minus 11 in the middle tells me both signs are minus. And I got to figure out, there's the guess part, I got to figure out what makes the 12, but then when I FOIL it, I get a minus 11 in the middle. So my choices would be like 1 and 12, 2 and 6, 3 and 4. But when you FOIL it back together, you're going to be multiplying one of them by a 2. Any ideas? We can guess and check. I don't mind erasing. 4 and 3? 3 and 4? So if I multiply that back together, I get negative 8x. And on the inside, I get negative 3x. And does that equal negative 11x? So I factored it correctly. After we have our factors, what do we do for each factor? You set each factor equal to 0. We're going to solve each factor. We haven't had ones like this to solve before. So I'm going to add the 3. I'm going to divide by 2, and I leave it as 3/2. On this one, we're going to add the 4, and we get 4. We get 3/2 and 4. We're going to do one more example. It is, I don't know what number it is. 9. Find the zeros of the function. What does it mean to find the zeros? Put 0 in for the f of x. And we're doing this by factoring. So we're doing this by factoring. We need a factor. What's our first step of factoring? Is there a GCF? Emma? It's x. So you're going to have to undistribute that x. So I'm left with x minus 8. And I could distribute the x back in just to check and make sure I had it correct. Distribute the x back in and I have it correct. Now we do have 2 factors. We set each factor equal to 0. What is our first factor? I'll give you a hint. It's the greatest common factor. X. So we set x equals 0. And we set x minus 8 equals 0. And we solve each of these. The first one's already solved. That's 0. The second one, add 8. So we have 2 answers, 0 and 8. I said that was going to be the last one. I'm actually going to factor the next one just to show you it, but I'm not going to take the whole time to go through the steps of factoring. I just want to show you, because the next one's different, but I don't want to go through the factoring steps. It's going to take a little bit longer to do that one. For this last one here, for 10, you put in the 0, and then you go and you factor that one. It ends up being 2x plus 7 squared. And you have to solve that for x. So you set each factor equal to 0. How many factors are there? And we set the parentheses here. 2. No, you're right. 2. Because it's squared. But they're the same. So one of them's 2x plus 7, and the other one's 2x plus 7. When I solve this one or solve this one, aren't I getting the same answer? So you don't need to solve both if it's squared. We're just going to get one solution for this one, which we had graphs that look like that. The solution would be negative 7/2 when you actually solve it. But that one would give you only one solution if they were the exact same factor. So I'm going to put up, it is Big Ideas Online. But if you have issues at home using it, you can do it on paper and then bring it in and type it in on the next 2 XH bells we have. I'm also going to give you graph paper because some of them say solve it by graphing. You might need some graph paper at home to solve it by graphing. I'll give you some. I got a lot. We'll have the graph paper. I'm going to give Carly a name. You talk to Carly, tell her to come get graph paper. Good talk to her. I think there's 2 there and there's stuff there. And if you need help on any of this, you come see me next day. Don't wait till it's the day before a test and you realize you don't know any of it. Tomorrow, come Thursday. What's that? Yeah, I can't hear what you're saying. I can get her tomorrow at 7:00. Okay. XH tomorrow and Thursday before I see you again. Don't decide you're going to start your assignment Thursday XH. You will not get done. You can even start it online or on the paper and then put it in online later. As long as you have a book. Pretty done. Excellent. Exams will be in tomorrow also. They are graded, they're in my bag. I just didn't have them, I'm gonna type them in after school, if you wanna know how to do them. Or you can just wait if you want to do it too. And I don't typically hand them back, but if you think, it was graded weird or wrong, or, if you think you bubbled them wrong and you should have a higher grade, you can always come up.
Excuse the interruption. Today, the Spanish Club will be meeting after school in the cafeteria.
Like not in-
Do not forget that if you're an FCCLA member, you are meeting in room 188.
I don't have the.
Model UN is meeting today. It does not give us any location, but they are going to be doing officer elections. That should be it for today. As always, go fireworks.
I wish we could find our NFL cuts to that recording.
Stephanie.
Oh my God, I have to think.
Yeah, like, ew. Or like,
I am.